We have a special offer for podcast listeners this week. It's half price of everything digital at New Scientist, and that includes access to the complete archive.
Yep, that's the complete archive, all our news, features, in-depth, everything. Half price for all our digital content is an amazing deal. So go to newscientist.com/halfpricedigital, that's all one word, and we'll put a link in our show notes to sign up for that.
Hello, welcome to New Scientist Weekly. This is the show that brings you a curated selection of the essential stories of the week, and our aim is to feed your curiosity. I'm your host, Rowan Hooper.
And I'm Penny Sarchet. Welcome to the show. This week we're joined by New Scientist journalist Madeleine Cuff in Egypt, Leah Crane in Chicago, and Michael LePage in London. On the show this week, we've got the oldest sentence ever written in an alphabet, why birds get divorced, and an incredible star with a solid surface.
We've also got this noise. And the only clue I'll give you at this stage is that the sound came to me from the European Space Agency.
We'll find out more about that later then. But we're going to start with climate because, of course, COP27, the latest international climate summit, is now in full swing. Our reporter Madeleine Cuff is in Sharm el Sheikh and she chatted with Rowan.
Hi, Maddie. So set the scene for us from Sharm el Sheikh. What's it like? What's the vibe?
Hello. Yes, so I've just arrived at the COP venue. It's very hot. It's about 30 degrees outside and there's very little shade and the sun is blinding. So that kind of makes navigation difficult. Lots and lots of people wandering around. Everybody's in search of some free coffee and it's just very busy and quite hectic and very expensive. But, you know, that's what climate summits are usually like. So nothing new there.
Yeah. You have to find the equivalent to Iron Brew because that's what kept me going at COP26 last year. So look, you've just been at a session. What was that about? Tell us about that.
So I've just been to the launch of a report that's done by Climate Action Tracker, which are a organisation which essentially look at all the different countries' climate targets and pledges and add them all up to see how the world is doing on its path to meeting the goals of the Paris Agreement. What they did this year was quite interesting because they added up all the pathways and all the pledges that countries have made, and they said that the world is broadly on course for 2.4 degrees of warming by the end of the century, which is basically what they said in Glasgow. So not much has changed there. What has changed, though, is the global appetite for new gas in the wake of Russia's invasion of Ukraine. So they've really focused some of their analysis on soaring demand for LNG, and they are essentially warning that the world has gone so mad in trying to procure new sources of LNG to make up for what Russia has pulled from the market that they have recruited too much new LNG to the market, and that could blow the 1.5 degree target over the next few decades. So it's really a really serious warning about the oversupply of new gas.
And is there any recommendation, I mean, other than the obvious, to stop doing that and to build more renewable?
That's pretty much the recommendation, yes, is to. Yeah. So a lot of these new gas projects are in planning or proposals, so they aren't built yet, and so there's still time for governments to reverse course and say, actually, no, we won't need all of that gas. Let's plough that money into renewables and green hydrogen and other low carbon technologies.
Yeah. I've been seeing a lot this morning about people up in arms about the amount of lobbyists there from fossil fuel companies. Have you seen any of that? And you know, when you go to a session on like the one you've just been to that's showing all the problem with all this natural gas expansion, is there anyone in the audience saying, "Oh no, it's all fine. We need this for," you know? Do you see anyone from who's clearly a lobbyist saying, "But we need this for the transition and because of Ukraine," and trying to make an argument for it?
So this was a press conference I was at, so all the journalists were very polite and not promoting the use of gas, but it's certainly sort of visible in the conference, and you see it from the very top down. Boris Johnson addressed the summit on Monday on the first day. Even he said that new gas might be needed to make hydrogen in Africa. So it really kind of starts from the top. And I was talking to a guy called Bill Hare, who's the CEO of Climate Analytics, which worked with Climate Action Tracker on this analysis. And he was saying that this narrative around gas as a transition fuel is still really strong, and captures a lot of people, and it's the presence of these lobbyists at summits like this where they make the case to negotiators, to politicians, to diplomats that gas is needed as a bridging fuel. And that's where that kind of narrative gets embedded into the structure of government policies. So it's definitely visible in what we're seeing in the kind of language that we hear.
And you mentioned 1.5, and we're on track for 2.4 degrees of warming. And I saw there was a session on overshoot. So that's the idea that, we're going to miss 1.5. Even the IPCC admits that, but then we come back down to it. That's interesting, isn't it? Is that softening us up or is that the IPCC slowly coming round to the idea that we are actually going to miss it and not be able to come back down to it? Or is it very genuinely that we need to understand what happens when we overshoot, when we get above 1.5 degrees?
I think it's probably a bit of both. I mean, you speak to scientists and you ask, is 1.5 degrees still viable? And they'll sort of squint and say, yes, theoretically it is. But, if we look at real world progress over the last few years, it's certainly not on track. But there is also, the 1.5 degrees target was really kind of embedded in the global consensus after the IPCC's report on what happens on warming after 1.5 degrees. And that was kind of breaking new ground in terms of the science of that threshold. And what they're now trying to do is to work out, okay, if you overshoot 1.5 degrees and then go back down, how much of what is triggered in that process is irreversible? So it's kind of the next step on from that landmark 2018 IPCC report on warming of 1.5 degrees.
All the heads of state have gone now, have they? Is there anyone still left?
The last big name on the list is Joe Biden, who I think touched down today and is due to address the conference in a kind of formal speech tomorrow afternoon. So I think that is the hottest ticket in town at the moment to get into tomorrow.
Yeah. I did see that there was an announcement before he got there about a nature-based solutions roadmap, which looked really interesting. I don't know if you had a chance to look at that.
Yeah, this is quite interesting. I had a quick look and it won't make headline news, but it is really interesting as an exercise in how to redirect the focus of a huge government machinery like the US into thinking more holistically about the fight to preserve biodiversity and to tackle climate change. So it's lots of interesting directions to different federal departments across the states to say, okay, if you are thinking about resilience to hurricanes or flooding, think about nature-based solutions first before you build a massive great seawall, for example. So it's trying to embed that kind of nature-first decision-making in all levels of government, which is quite an interesting exercise.
Yeah, and it's good to see it being announced by the top dog, basically, as well. The other thing that people have been talking about a lot is loss and damage. And that's the idea, that rich countries pay the vulnerable countries, poorer countries, they pay reparations for climate damage that those countries are suffering. So, you've just been at a session on that as well.
Yes, so I have just been at a session that was looking at the scientific basis for loss and damage, really. So there's kind of two distinct ideas. There's loss and damage, capital L, capital D, which are those big, complex and very fraught negotiations that are underway at the moment on how to create some sort of fund that would help countries out in a time of crisis. And that's what they're talking about in the formal negotiations. But what underpins that is the science of loss and damage, which is essentially a really developing area of science. It's part climate attribution, so part looking at the floods in Pakistan, for example, and saying, well, how much of that is actually due to climate change? And the science on that has advanced hugely in the last few years. But it's also about looking at the limits of adaptation and to say, okay, in this part of the desert, there is no more that humans can do to adapt to live in this environment. And so if warming goes above a certain threshold, then loss and damage is incurred that is unavoidable. And what happens then? How do you quantify that? How do you benchmark that? And so that's the kind of the science that is underpinning these really fraught and tension-filled negotiations.
Great. Thanks, Maddie. We'll let you go and get some coffee. Hope it doesn't get too hot.
Thanks so much. Speak to you soon.
That's the Sci-Fi Alert, when we report on something that we've already heard about in science fiction. Leia, this week it's a star with a solid surface. What is that?
It totally blew my mind when I heard about it.
Yeah.
It's this super weird star, about 13,000 light years away, and it seems to have a solid surface. It's not a normal star, it's a magnetar, which is sort of a dense corpse of a star that exploded in a supernova. But we have never seen anything like this before.
All right. So what happens when a normal star explodes? It kind of just goes into gas, right?
So, when a normal star explodes, most of it sort of dissipates away and then it becomes a neutron star or a black hole. But we think that neutron stars, and a magnetar is a type of neutron star, and we think that usually they have a sort of surface just like any regular star that's sort of like roiling plasma.
Right.
So, this one's so weird.
And so how do we know it's solid then and not this roiling plasma?
The researchers did these measurements on polarization, which is sort of the direction the light wave is wiggling. And what they found is that it looks like the light is coming straight off a solid surface. It doesn't look like it's traveling through an atmosphere first, which is what it would look like if the star wasn't solid on the top.
Right. Right. Okay.
It's less polarized than it would be because an atmosphere acts like a filter and polarizes the light. And this light is not traveling through an atmosphere.
And do we know what magnetars are made of typically? I mean, can we tell from 13,000 light years away what this is made of?
So we think that the surface of this one that lies sort of atop all that other stuff in the middle is made of a thing called a Bingham plastic, um, which the best example would be like mayonnaise or toothpaste. It's something that is sort of solid in some conditions,
Okay.
but behaves like a fluid a lot of the
Okay.
time.
So plastic in the sort of sense of how it moves, rather than what it, as we think of as plastic. Okay. So does that mean you could land on it if it's cold now? Is it cold enough to land on and it's got a solid surface?
So I asked the researchers this, and they
Of
laughed
course
at
you
me.
did. Yeah.
Of course I did.
Yeah.
And they laughed at me. One, it is super, super hot
Right.
still. But the other thing is the gravity on this thing is so strong because it's so dense that the gravity at your feet would be a lot stronger than the gravity at your head. So if you got close
Wow.
enough to land on it, you get stretched out and spaghettified.
Whoa. And not just that, but would that mean time would run differently at your head than it would at your feet?
Absolutely, it would.
Whoa. Because yeah, we know that, like, because so a clock would run differently. So if you're in orbit around it and you sent a probe down, I don't know which way around it would be, but you might have to wait for years in orbit while the thing only has a minute on the surface. Or would it be
I,
the other way around?
I think it's that way around.
Okay. Wow.
Yeah, so your head would age a lot faster than your feet would, which seems absolutely wild. Of course, you wouldn't notice because you would be super dead.
Yeah, of course. But that's just a minor matter when we want to talk about all this crazy time stuff. But Leia, while you're here, there's another amazing story from the IceCube Neutrino Observatory in Antarctica. So it's detected neutrinos, but then it's plotted their trajectory all the way back through the universe to the galaxy where they came from.
Yeah, and it is really hard to do that. You think it would be easy. You're like just following a neutrino, a particle back to its home. It is super hard to do that because one, it's hard to detect neutrinos. They move through just about everything. And once you've detected them, to trace them back to an actual object where you know what the object is in the whole sky, it's extraordinarily difficult. And they have gone back through all of this data and traced them all back to one little galaxy in sort of the distant universe.
Wow. What a piece of work. We'll put a link to that in the show notes and to the other story.
So, Rowan, I wonder if you've forgotten something. What is the sci-fi you're trying to link this to?
Oh, it's for the Magnetar story. So the time dilation effect reminded me of this wonderful space epic called The Ballad of Halo Jones by Alan Moore and Ian Gibson. And at one point on that, the characters go to this planet that's got real extreme gravity that means time runs at different speeds. And also, while we were talking, it reminded me of Interstellar when time runs differently according to whether they're in orbit or on the surface of that planet near the black hole.
Right, the one with the huge waves.
Yes. And now a word from our sponsor, Dream Machine. Which is heavier, red or yellow? Did the answer come to you automatically? For me, it's red. But why?
Many people make associations between unrelated things, but there's no clear reason why. Introducing the perception census. This is a new scientific study exploring these quirks of the mind. By taking part in a series of games, illusions, and brain teasers, you can explore your powers of perception and help scientists and philosophers understand why we all experience the world in our own unique ways. With your help, this will be the largest study of its kind into perceptual diversity. If enough people take part, it will transform our understanding of how and why we each experience the world differently.
Led by world-leading academics, Professor of Neuroscience Anil Seth from the University of Sussex and Professor of Philosophy Fiona Macpherson from the University of Glasgow, this groundbreaking study is part of the Dream Machine programme. To take part, please go to perceptioncensus.dreammachine.world and we'll put a link in the show notes.
Now, the 15th of November is the day that the UN has chosen to mark the point that the global number of people on this planet passes 8 billion. It's only actually been 11 years since the population hit 7 billion. And Michael, it seems like the world's population is growing faster than ever, but that's not actually the case, is it?
No, in fact, fertility rates are falling fast pretty much everywhere. In sub-Saharan Africa and parts of Asia, they're still well above the replacement level, so the populations there are still growing fast. But in the rest of the world, including India, fertility levels have already fallen below the replacement level.
I was really surprised by that. Does that mean that in most places then those populations are falling?
Well, they will start falling, but there can be this lag between the fertility level falling below the replacement level and that population starting to fall when you've got a lot of young people in the population. So India's population, for instance, is expected to keep growing until around 2050 before it starts falling. But the populations of many countries in Europe and elsewhere are already falling, or would be if it weren't for immigration.
Can you give us an example then of a country that's dealing with this?
Yeah, so Japan is the obvious example. Its population peaked at around 128 million in 2008, and it's already fallen to 124 million, so that's a pretty big fall. And what's more, its fertility rate is still going down, so the rate of decline is going to accelerate. But the one that really surprised me is China. So it's got a population of 1.4 billion today, but it's expected to start falling soon if it isn't already, and it could halve to 700 million by 2100. So that's pretty dramatic.
Wow, that's staggering, isn't it? And, when we're talking about such big declines in some of the most populated countries in the world, what does that mean for the world population overall?
Well, it's now expected to peak sometime this century. So a few years ago, the UN was predicting that the population would hit 11 billion by 2100 and that it would sort of keep growing after that. But its latest forecast this year is that the world population will peak in the 2080s at around 10.4 billion. And there are two other forecasts that see the peak coming even earlier by around 2070, long before the population even hits 10 billion.
So this sounds like it might be good news then in terms of climate change and, how many people the world can support without collapsing under the weight of us all.
Yes, so we've got to be a little careful about that. It's the number of rich people that matters when it comes to environmental impacts, not so much the number of people overall. But yes, generally a smaller population certainly helps. And of course, there are some benefits of falling populations, such as more space, lower house prices, and so on. But governments tend to see this as a huge problem because you have aging populations with a falling proportion of people of working age. So some countries are already actually trying to boost fertility. And I think more and more countries are going to follow suit.
And if that happens, could that then throw these projections off and maybe the global population won't peak that early after all?
Well, this to me is one of the really interesting aspects. So what the researchers I spoke to said is that it's relatively easy to lower fertility levels, but really hard to raise them. So the government programs that are trying to boost fertility tend to have small effects and it tends not to last very long. And actually, if you think about why people are not having children, that makes sense. You can see that in many cases, governments are going to have to offer pretty big incentives to change people's minds about having children or not. So the bottom line is that we're actually starting to enter an age of population decline, and it's going to be really hard to do anything about it.
Yeah, well, you mentioned Japan, didn't you? And the obvious thing to do something about it is to increase the amount of immigration into your country. And we were discussing this on the podcast a few weeks ago with Gaia Vince, because that's what her new book is all about. I mean, that's an answer to the problem, but it's easier said than done, isn't it? Because as you've been talking about Japan with these low fertility rates for many years, but it can't bring itself to increase immigration to the country.
No, and certainly the researchers I spoke to expected that there wouldn't be any major increases in migration allowed for the obvious political reasons.
Next up, we've got a study on divorce in birds. Penny, what's the latest on this?
Well, this is really interesting. It's a look at breakups in 232 species of bird, and it found that species that migrate particularly long distances tend to have higher rates of splitting up.
So what do we mean by divorce when it comes to birds?
Well, one thing that's really interesting in birds is that most species are, by and large, monogamous, and they form couples to raise offspring. And in many species, these same couples are likely to raise multiple broods together within a season or even year after year. But even in species that do that, which we often refer to as mating for life, they're not actually tied to each other forever. And individual couples do split up and start afresh with different partners from time to time for various reasons.
And so if you're a long distance traveler and you know that means you're less likely to stay together, is that like literally because you get separated during the long distance travel?
Yeah, so that probably is a factor. Just because they breed together, it doesn't actually mean they spend the whole year together like a married couple necessarily. So, for example, they may spend the whole winter apart and then sort of meet up when they get back to the breeding grounds. So one idea is that those that have to travel a really long way to get to their breeding grounds, they might be less likely to arrive home at the same time. And if you're the first one back, you face a bit of a dilemma. You can wait for your partner, but of course, you don't have a mobile phone. You've no idea if they're actually still alive and if they're going to make it, or you can mate with someone new. And so, for example, from this study, great blue herons, they migrate more than 3,000 kilometers and they have a divorce rate of 100%. So they just choose a new partner every time.
It's hard not to anthropomorphize this sometimes,
Yes.
isn't it? But when you put it like that, I mean, it makes you wonder why bother in the first place if you're a long distance migrator.
Yeah, to stay together. There are some reasons, because if you've successfully raised a brood with a previous partner, you already know they're a good co-parent and that you're a good team. And also one thing that sort of made me laugh a bit was that it can also take a lot of energy and effort to bother to court someone new.
Yeah, for sure.
So that's that on anthropomorphism again. But there are some long distance species that they do seem to have adapted to make sure that they can find their partners. I thought this was really interesting. So Icelandic black-tailed godwits, for example, that's a pretty wading bird. They can spend their winters in completely different parts of the UK, but somehow they manage to synchronize their return to Iceland nearly perfectly, and we don't know how.
Yeah, well, I saw that. This is a great story by Alice Klein, and we'll put a link to that in our show notes. And there's also been some more godwits in the news, hasn't there?
Yeah, it's all go for godwits. It's actually been a great month for news on migration. There's a lot of it about at the moment. And a few weeks ago, we heard about the longest non-stop migration flight ever recorded. That's in a slightly different species, the bar-tailed godwit. And a subspecies of this bird has one of the world's longest migrations. It breeds in Western Alaska before flying right down the middle of the Pacific Ocean without taking any breaks to New Zealand or Southeast Australia.
Oh.
And so this time, they recorded a particular individual flying 13,500 kilometers down to Tasmania in just 11 days and 1 hour with no stopping.
Oh my God. That's absolutely amazing, isn't it? How
Yeah,
did
it's
they
just
do that?
incredible.
So they must do these micro sleeps on the wing like Swifts do and just literally sleep while flying.
It just sounds so exhausting.
Yeah.
But I've been really interested in this recently. So in my next wildlife newsletter, which is out next Tuesday, that's all about this species and several other of the birds that fly so long and so far that essentially they just live in endless summer because they go from summer at one end of the earth to the other.
Endless summer.
Mm.
Great. Listeners can sign up and receive Penny's free Wild Wildlife newsletter. Go to newscientist.com/wildwildlife and we'll link to that as well in the show notes.
This week, we saw the news of the discovery of the oldest readable sentence written using the first alphabet. Rowan.
Yes, and thank you for putting that very carefully, because it's not the oldest sentence in the world by any means, but it's the oldest sentence, as you say, in the first alphabet, because, there were lots of writing systems before then, but they were hieroglyphics and symbolic writing, and it wasn't in an alphabet.
So yeah, good to make that distinction.
Mm.
But dying to know, what did it say?
Yeah, you might think it says something really wonderful about, the afterlife or something, but it's written on the side of a comb, an ivory comb, and it says, "May this tusk root out the lice of the hair and the beard."
It's instructions on a knit comb.
Yeah, it's a knit comb. Yeah, literally made to remove head lice and beard lice. It was found at an archaeological site in southern Israel. The site's about 2,700 years old, but the style of the writing dates it back another about 1,000 years. So it puts this at about 1700 BC.
Wow, that is amazing, and what a
Mm.
glimpse into life. Then
Yeah.
does it tell us anything about the origin of alphabets?
I thought you'd say the origin of knits. No, the origin of alphabets. Well, I mean, knits have been with us all the time as well, actually. We have written
Mm.
about that before. The origin of the alphabet is a bit more mysterious than knits because, we know that the first writing emerged in Mesopotamia and Egypt about 5,200 years ago. And those were the non-alphabetic ones, But then the alphabet was kind of invented probably in Egypt somewhere. And that was when hieroglyphs were repurposed and simplified to form the sort of alphabetic letters that we know of now.
So what sort of language is this in then? And do people still sort of read these languages? Do they find it easy to decipher it?
Yeah, I wondered about that. So the language is an ancient Canaanite language, and it was spoken at this site that they found, this archaeological site. But what was funny was apparently it was easier for the team to decipher the inscription because on that comb, the knit comb, there were still exoskeletons of dead lice. So it literally gave them a clue as to what the thing was used for. It gave them a prompt as to what the
Oh,
thing might be saying.
that's amazing and gross simultaneously.
Yeah.
And just to say, we do, of course, have texts that are older than that head lice sentence. So, of course, there's the Epic of Gilgamesh that was written around 2100 to 1200 BCE. And there have been some funeral texts found in Egypt called the Pyramid texts, which are around 2400 to 2300 BC. But still, quite amazing.
And that's all for this week. Thanks to guests in the pod, Madeleine Cuff, Leah Crane, Michael LePage, and thanks to you for listening.
Do tell everyone about our show and subscribe so that you don't miss an episode.
And that noise you can hear in the background, now's the time to reveal what it is. It's the sound of Earth's magnetic field.
Ooh.
Yeah, this is from the European Space Agency, and scientists there took magnetic signals that their satellites had measured and then have converted them into sound. So enjoy this actually quite weird noise, and see you next week.
Bye.
Bye.
This podcast is produced by OG Podcasts. Find out more at ogpodcasts.co.uk.